All right, welcome to the Explainer. Today we're digging into two of the most common and probably the most confused things you'll find in your potting soil. Yeah, I'm talking about perlite and vermiculite. They might just look like little specks and flakes, but trust me, as we're about to see, they are worlds apart. So you've seen them, right? You open up a bag of potting mix and it's full of these little white rocks or kind of shiny golden flakes. Now, it's easy to think they're just filler, something to bulk up the bag, but nope. They're actually very specific minerals, put in there on purpose to completely change how that soil works for your plants. And this is really the whole story, the heart of the showdown. Think of it like this. Perlite's main job is to create space, little air pockets, and let water just rush right through. It's all about drainage. But vermiculite, its job is the exact opposite. It's basically a sponge, designed to soak up as much water as possible and just hold on to it. So yeah, two totally different, even opposing jobs.
So the big question is, how can two things that look kind of similar and are often in the same soil bag be so different? Well, to get that, we have to go way back to where they come from. One is literally born from volcanic fire, and the other is formed from weathered down rock.
Okay, first up is perlite. It actually starts its life as obsidian. You know, that black volcanic glass? It's formed when lava, super rich in silica, cools down so fast that it can't form crystals. And in that process, it traps tiny little water molecules right inside its solid, glassy structure. So you can literally think of it as a water-filled volcanic glass. Vermiculites, on the other hand, is a whole different beast. It's not volcanic glass. It's a type of clay mineral, kind of a cousin to mica. So instead of being a solid chunk, its structure is made up of these super thin crystalline layers. It also traps water, but it holds it in between these tiny little sheets, almost like water soaked between the pages of a book. Now here's where things get really cool. How do they go from being hard rock to those lightweight little bits we see? Well, they both get popped, like popcorn. Seriously, they crush the raw mineral and then they blast it with insane heat. We're talking over 800 degrees Celsius. All that trapped water inside, it flashes into steam instantly and pop, the whole thing explodes and expands. Perlite puffs up into those familiar white balls, and vermiculite's layers separate and open up like a little accordion. Okay, so now that we know how they're made, let's look at their first big showdown, water. This is really where those unique structures we just talked about start to matter a lot. And this chart just lays it all out perfectly. Look at perlite. It's barely holding any water. Why? Because it's not really absorbent. It might hold a little bit on its rough surface, but its real job is to take up space and create air channels so water can just drain right out. But vermiculite, whoa, it is a super sponge. It can soak up 3 to 4 times its own weight in water. It's a massive water reservoir for your plant's roots. But water is only half the battle. Their next big fight is over something just as critical for your plants: nutrients. Okay, to get this, we need to talk about a slightly sciencey term, cation exchange capacity, or just CEC. It sounds complicated, but it's not, I promise. All it means is a soil's ability to grab and hold onto essential nutrients. You know, the good stuff, like potassium and magnesium, so they don't just wash out the bottom of the pot every time you water. Think of it as a nutrient battery or a nutrient magnet. And this is where vermiculite is an absolute champion. Because it's a clay mineral, it has a negative charge, which means it has a really high CEC. It acts just like that rechargeable battery, grabbing onto all those positively charged nutrients from your fertilizer and storing them up, releasing them slowly for the plant's roots whenever they need to. And perlite? Well, since it's basically just glass, it's chemically neutral. Its cation exchange capacity is, well, it's pretty much zero. Nothing. It holds on to zero nutrients. It's great for structure and drainage, but when it comes to feeding your plant, it's bringing nothing to the table. Okay, so we've got the science down, the drainer versus the sponge, the nutrient battery versus the empty plate. So what does this all mean for you and your plants? How do we actually put this knowledge to work? Here you go. This is basically the cheat sheet. If you've got plants that absolutely hate having wet feet, I'm talking succulents, cacti, aroids like monsteras, you're going to want to go heavy on the perlite for that drainage. But if you're starting seeds or trying to root cuttings that need to stay consistently moist, vermiculite is your absolute best friend. And a special case, carnivorous plants, perlite only, because they're super sensitive to the minerals that vermiculite can release. And trust me on this, getting this wrong is one of the most common ways people accidentally kill their plants. If you put vermiculite in a succulent mix, you're basically just asking for root rot. And if you try to start delicate seeds in a mix that's mostly perlite, they're likely going to dry out and wither. So yeah, this choice really matters.
All right, but before you run off to the garden center to repot everything, hold on. There's some important fine print we need to cover. Let's talk about safety, some potential toxins, and the bigger picture of sustainability.
First up, let's talk safety. That dust from a dry bag of perlite, it contains silica, which is really not good for your lungs. And with vermiculite, there's a historical issue. Some stuff sold before 1991 from one specific mine was contaminated with asbestos. Now, modern vermiculite is totally safe, but here's the simple, foolproof solution for both. Just wet them down before you work with them. Add a little water to the bag, mix it up, and boom, no dust. Okay, here's a mystery that drives so many plant parents crazy. Have you ever had this? Your Dracaena or your spider plant. You swear you're doing everything right. Perfect watering, good light, and you still get those ugly brown crispy tips on the leaves. What in the world is going on? Believe it or not, the culprit might be your perlite. It can actually release tiny amounts of fluoride, and for certain plants, that's toxic. The plant transports that fluoride all the way to the very tips of its leaves, where it builds up and causes that burn. The good news? The fix is so simple. Just take your perlite, put it in a strainer, and give it a really good rinse with water before you mix it into your soil. That's it. And one last thing to keep in mind, something that's really important. For all the great things they do for our plants, both perlite and vermiculite are mined resources. They're dug out of the earth and they aren't renewable. Plus, remember that popping process? That takes a huge amount of energy. But the good news is there are some really great sustainable alternatives that are becoming way more common. Things like biochar, which is cool because it helps with both aeration and holding nutrients. There's pumice, which is basically a less processed version of perlite. And then there are things like rice hulls, which are a fantastic renewable waste product from farming. There are options out there. So next time you're mixing up a batch of soil, you're not just throwing in some white rocks. You know exactly what you're choosing and why. You're making a choice between drainage and moisture retention. But you're also facing a bigger choice, aren't you? The one between these effective but mined minerals and a more sustainable future for our soil. That choice is in our hands.